Yeah, so I'm recording now, and I guess I don't really need to be recording, but what I had mentioned before I hit record was that yesterday we did question 5, which was a little bit challenging. I made a mistake when I was doing it, so it was maybe a bit confusing. But today I'd like to show you another one with number 6. Now, before I do number 6, I would like to see if anybody could try this and get the answer. So remember, we're trying to solve for x and y. The idea is we're trying to mix in this question, we're trying to mix two chemicals together to get 100 milliliters of a 5% solution. We have a 2% solution and a 7% solution. So the 2% and the 7 we will call x and y respectively. And and I should mention that the volumes are x and y. The solutions are 2% and 7%, which are x and y in terms of volume. We want to figure out what quantities, which would be our volume in milliliter, of each would we have to use. So for anybody who was confused yesterday, I am going to go through the answer here, but I would like to give you guys a couple of minutes to try this to see if anybody can do it. So I'll put myself on mute and I'll give you guys a couple minutes to try this. And if you still don't get it, no worries. I'm going to show you this one again. So how about you take 3 minutes, and at 1:55 we'll look at the answer. And again, give this a good try. So I'll be back in 3 minutes. All right, we'll go through the answer here in 1 minute. Ooh, Dustin, very good. Yeah, that's exactly what I got. I just did this one myself. I really wanted to make sure that that I didn't make any mistakes with this one. So I did this one just as you guys were working, and I got 60 milliliters of the 7% and 40 mils of the 2%. Cool. So I'll just give you guys another minute to finish this off. And great job, Dustin, by the way. And then I'll go through the answer with you. I'll show you where these numbers come from. This is on your assignment, this type of question. So this is definitely one you want to pay attention to, because I think this is like the last question on your assignment this week. Your assignment is only 6 questions, so it's pretty easy, but this is one of the harder questions. So yeah, just finish it off, and in less than a minute, I'll show you how myself and Dustin and Fatima, good job, got the answers. Okay, so let's go through this, and hopefully I'll explain a little better than yesterday where these answers come from. Okay, so I'm going to do this a little differently than yesterday as well, because I shouldn't say differently. It's just I ran out of room yesterday, so I'm going to kind of change it up a little bit. Okay, so we are going to create a table to organize our information. And you'll kind of see, instead of doing the table twice, I'm just going to erase something. So you'll see what I mean in a minute. So we have let me zoom in one block here. Hopefully this will be okay. So we have a 2% solution, and we have a 7% solution. And what we're going to do is we're going to let the volume of this. Now, I said volume, and what I really mean is the milliliters. Sometimes my brain, makes me want to talk like I'm teaching chemistry instead of math. So milliliters. The amount, the quantities in milliliters, we're going to say that the 2% solution is X and the 7% solution is Y. Okay, so the percentage of these solutions as a decimal, we're going to write as 0.02 and 0.07. Sorry about that. So remember, I had this question yesterday. To change a percent to a decimal, we divide by 100. Okay, so that means the total of X and Y would just be these two multiplied together. So I get 0.02X, 0.07Y. Again, all I'm doing is multiplying the first two columns together. So this is a table. Okay, and then the last one in the table is the mixture. So the mixture, and this one's really interesting. This is kind of our main formula for this. I didn't give myself much room. Hold on. I'm just going to clean up my table here. So my mixture, I'm trying to add together X and Y to make 100 milliliters of solution. So the mixture is X plus Y equals 100. That's my main formula going forward. I'm trying to add X and Y together to make 100 milliliters. And the final concentration must be 0.05. So when I multiply these together, I'm going to take 0.05 and multiply it by 100. And that's equal to 5. I'm going to need that number in a minute. Okay, I'm almost ready to solve this. Now, I'm going to use the substitution method. I know that X plus Y equals 100. So I'm going to solve this for X. And this is where I made one of my big mistakes yesterday. I had the equation reversed. I made a big mistake yesterday, which might have confused you guys. But X plus Y equals 100, I can solve this. I know that X I can substitute or solve as 100 minus Y. So what I'm going to do up here, instead of drawing the graph 2 times, so up here, instead of X, I'm going to erase that and I'm going to write in, and I'll pick a different color. Ooh, I don't know if I can pick a different color. I'm in like a weird mode. Okay, I'm going to try something. Wish me luck here, guys. I hope I don't mess anything up. Okay, it's looking good so far. Oh, sorry. I want to do this in blue so you really see what I'm doing. There we go. Boop, boop, boop. Okay, sorry. So instead of X here, I'm going to replace that with 100 minus Y. And instead of this X over here, I'm going to replace that with 100 minus Y. All right. So now I'm ready to finally solve this equation. What I'm going to do is I'm going to add all of this together to solve. What I mean by add all of this together is that I'm going to say, 0.02 times 100 minus Y plus 0.07Y equals 5. Okay, again, I made some mistakes. I shouldn't say I made mistakes. Well, I definitely made mistakes yesterday. I just mean there was a couple numbers that I didn't calculate correctly, and it really messed up my explanation. So hopefully this is making more sense. This is a very tough question, by the way, compared to like if you look at number 4 or number 3 or number 2. I mean, this one's a lot more challenging. This one is on your assignment, but I think for your test, you'd probably want to study some of the other ones. All right, so now I just got to solve for Y. No big deal here. I'm just going to solve this equation for Y. So 0.02 times 100 is 2 minus 0.02y plus 0.07y equals 5. And then I'm just going to keep working through this and solving it. So what I end up getting is 0.05y equals 5 minus 2, which is 3. And y would then be 60. Whew. So finally, I can solve for x. X is 100 minus y, or 100 minus 60. It's 40. And that's my answer. Wow. Not the easiest question, is it? At least it's not like 7:30 in the morning. At least it's, 2 in the afternoon. But that's a tough one. And it is on your assignment this week. So make sure you have a look at like number 6 and number 5 to practice. Yes, there's a question. I heard somebody's mic, maybe not. Okay, guys, so I'm going to zoom out. I'll let you guys kind of absorb that. Just give me 1 minute. I have to grab something, and then we're going to start, excuse me, the next section in this book. That's it for word problems. So if you guys can do, wink, wink between us, if you make sure you're comfortable with practice problems 1 to 6, you are fine for any type of word problem you would ever see in this course. So just give me 1 minute, try to, absorb number 6 here, and I'll be right back to move into the next section. Okay, sorry about that. I just had to grab something really quick. Okay, so let's move in. Oh, well, that's it, I guess, for the first part. That's it for Unit 1. This course is, personally, this course isn't really broken up for me into units. It's more of into topics or sections. So we just finished word problems, which was section, I think, 11. Yeah, or topic 11. So we're going to move into topic 12 today. Your test on Tuesday next week goes up to topic 14. Don't worry, topics 12, 13, and 14 are pretty short. And as I mentioned last day, we will have a tutorial Monday evening for your test on Tuesday. I think we actually have class before your test from 9:30 to 11:30, so we can do some more tutorials or if you guys have any questions before that. So let me open up the new book, and we'll start with topic 12. I think, yeah, okay, just double checking. So give me a second here. I'm really congested today. I think sometimes when the weather changes, like if the, pressure in the air changes, I get like congested. I get stuffed up. I don't know why, but anyways. All right. So what I'm doing, by the way, guys, I'll share my screen here. I'm just opening up Unit 2. Now, again, like I don't like to think of this course as 4 units. It's mostly topics. So we've just finished 10 topics. I say 10 because we skipped topic 10. So in Unit 1, let me just write this here. In Unit 1, we did topics 1 to 11, but we skipped or we omitted 10. Make sure when you're studying, you do not study topic 10. You're going to waste your time. It's not a bad thing to know. I mean, like, there's nothing bad in this course, but don't waste your time studying topic 10. So we're going to do topics here, 12 to 14, and that's what's on your first test. It seems like a lot, but it's only because it's intercession that this seems crazy. If this was a regular semester, this wouldn't be very, very different. Well, it wouldn't be different at all. So topic 12, 13, and 14 is about polynomials, which of course, I'm going to open up in Power or sorry, Adobe to show you, but this is where you can get all of your course notes. So let me just show you that again, because it's been a long time since I've done this. This first section over here, there's two really important sections here. You have the recordings that I put on YouTube and then the print me course notes. In the print me course notes part is where you get your, most of your information. In here below, you can get things like sample quizzes and sample tests, which I highly recommend looking at. All right, and I would look at that definitely if you get a chance this weekend. But anyways, I am here in the print me, and I'm looking at course notes for number 2 or unit 2. All right, and I'm just going to download this. Hold on, I'm going to do something a little different here. All right, I'm going to share my screen. Here we go. So again,
yes, topic 1 to 9 and 11, 12, 13, 14.
Exactly. Yep. So again, what you just said is perfect. Can I write here? Yeah. So when you're studying for test number 1, we are going to study topics 1 to 9 and 11 to 14. And we're starting 12 right now. Don't worry, 12, 13, and 14 are actually pretty easy. I'm more concerned, I shouldn't say concerned, but I'm thinking that topics, say 8, 9, 10, and 11 will be a bit more challenging for everybody. 8, 9, 10, and 11 would be like graphing and solving equations. I don't think you guys will have much problems with the topics 12 to 14. So let's get this started here. Again, I don't like thinking of the math course as books 1, 2, 3, and 4. I like thinking it as topics. And what we're going to do in unit 2 is, as you can see, maybe it's a scary word for some of you. It's a word that comes from Arabic, by the way, but we're going to continue with algebra. Okay, algebra 2, we're going to move a little deeper into the world of polynomials, I guess is the fancy way to say it. So, what is topic 12? What is a polynomial and what can we do with it? We're going to look at one of the most important topics for anybody who is going to do more math courses at the college. The college is turning slowly into a university. Some of you guys are doing engineering or medical science or business, and you will be doing more math courses in the future. And one of the most important things you're going to take away from this is factoring. Factoring is very useful when you study types of math like calculus, which might seem like a scary word, but a lot of you guys will be doing calculus. Sorry, I have a message in the chat there. I'm unable to find topic 11 recording on YouTube. Is it there on YouTube? I haven't put it on YouTube yet. I can do that after class today. That was a question, a private message from Amar. I'll say your name. So Amar, if you were in class yesterday, that's what I did yesterday. I'll have that class uploaded on YouTube after this one. I haven't updated my YouTube yet, but I will after class today. So you should see topic 11 on YouTube and then today's class on YouTube after this one, of course. Okay, so what's a polynomial? A polynomial is an algebraic expression that has multiple terms. So the big one that we're going to look at in this course is trinomials, and then we'll look at cubes and squares, and I'll show you that in a few minutes. But the big one is trinomials, which is 3 terms, hence the word tri. So a polynomial is, an algebraic expression that has multiple terms. So to start this, first things first, recall what we did back in probably, I don't know, chapter 2, chapter 3, or topic 2, topic 3, sorry, multiplying polynomials. We used the distributive property, or factor, or I guess not factoring, but like reverse of factoring, to actually figure out how to, I guess, what we would call in math, expand these polynomials. So 3x squared times x is 3x cubed. We had 2 x's. We multiply it by an x. We have 3 of them now. 3x squared times 4. Well, we multiply the 3 and the 4. We get 12, and we keep the x squared. No problem. This one here is a little different. You might not remember this, or you might maybe haven't done this in a long time. This is I keep wanting to say factoring, but this is expanding this using what we would call in math the FOIL method. The idea is we're going to multiply each term by the 5x. So this would be the first, outside, the inside terms, and the last terms. It's a double distribution. This obviously is not what we're talking about here, though, because what I'm trying to say is when you reverse these steps, we are what's called factoring the polynomial. So, I didn't mean to like go fast through this information up here. I'm just saying factoring is going backwards. So factoring is taking something like 3x cubed minus 12x squared and turning it into factors. Very useful for calculus. Okay, like very useful. So anybody moving deeper into math, and I say this to anybody looking at the university program, engineering, medical science, whatever, I mean, this is very, very useful. Yes, I have a question in the chat there from Nasser. Topic 12 to 14 is in book number 2. So what I'm going to show you today is how to factor polynomials. So the first way, sorry, I didn't mean to like jump there. It's just the way the page goes. It looks like it's jumping. I think I can fix that actually. Hold on. There we go. So, there, not as scary when I do it this way. So the first way to factor polynomials is to consider the greatest common factor, the GCF. This is my favorite way to factor. This is the easiest way that, kind of like solving a puzzle. So this method is the greatest common factor method. Recall or remember, what is the greatest common factor of numbers? Well, the GCF, or greatest common factor of a group of numbers, is the greatest or largest number that is a factor of those numbers, which I know that might not make a lot of sense. That's like defining a definition by describing the words in it. But what I mean is it's the largest number that would divide exactly into the numbers in the group. So what do I mean? Okay, take the numbers 8, 12, and 4. Or sorry, take the numbers 8 and 12. When I think of the numbers 8 and 12, I need to consider a number that divides evenly or exactly into 2 of them. I know 1 divides into all of them, right? Like 8 divided by 1, 12 divided by 1, obviously that works. What about 2? 8 divided by 2 is 4. And 12 divided by 2 is 6. So that's good. But I think there's a bigger number here. And that bigger number is 4. There's nothing bigger than that. So 8 divided by 4 and 12 divided by 4. This is the greatest common factor, 4. 4 is the biggest number that goes into all of those numbers. Okay, what about the next example? 20, 30, and 15. Now, if it was just 20 and 30, I would say 10. 10 is probably the greatest common factor. But unfortunately, I have 15. And the biggest number that goes into these numbers is 5. 4, 6, and 3. So the GCF is 5. The greatest common factor is 5. Okay, so what does this mean? I don't know why I'm erasing that. I guess I don't need to. What does this mean for polynomials? The greatest common factor of a polynomial is the largest monomial that divides into each of these terms, which means you need to find the greatest common factor of the coefficients, and you need to find the greatest common factor of the variables. So this is new. What you do is you look for a variable that is common in all the terms. So here I have 2 terms, by the way. So remember what a term, the reason I'm emphasizing this is you're going to hear me say term a lot. Terms are the numbers in algebraic or the groupings in algebraic expressions separated by a plus and minus sign. So I have 2 terms here. Again, I'm up here. So the greatest common factor of these terms is, well, I need to figure out the GCF for 9 and 6. That's, of course, 3. But what about these x's? What do I do here? Well, you look for a variable that is common to all terms. Each term has 1 x. So my GCF for this guy is 3x. I can remove or divide from each of these 3x. There's nothing else that they have in common. So once you've figured out your GCF, you remove it from the term. I'm going to show you this, guys. Don't worry. So what about example number 2? What's the GCF for these guys? Okay, well, let's forget about these steps. Let's think about this. We have 8, 12, and 20. So I need to think of a number that goes into 8, 12, and 20. So 2 definitely goes into all of these numbers. But I think I can come up with one bigger, and that's 4. 4 can definitely go into 8, 12, and 20. 8 divided by 4 is 2. 12 divided by 4 is 3. 20 divided by 4 is 5. That's perfect. Now, what about the other numbers? This has an A. This has an A. So guys, very important to follow my pen. I'm writing here. This has an A. This has an A. No A. So A is not a common factor. I cannot use A here. However, this has 4 y's. This has 3 y's, and this has 2. So from minimum, I can remove at least 2 y's from each of these numbers. Halas, that's it. That is my GCF, 4y squared. I can remove a y squared from each of these. That's it. That's all you have to do. So let's practice. What is this stupid? I hate this light bulb. What does this light bulb have to say? The light bulb says, Sorry for coughing into the mic, that my bad. The GCF of a polynomial must divide into each term exactly. Of course, light bulb, we know that. Okay, forget about this stupid light bulb. All right, so I would like for you guys to practice. There's a ton of practice you can do here. Why don't you guys take a couple minutes? And yeah, sure, why don't you try 1A and B? That's a good warm up for numbers. But then try, I don't know, try B and D here. I'll do A and C, but why don't you guys try these? So try question 1, try question 2. I definitely want you to try B and D, and I'll of course show you A and C in a few minutes. All right, so take your time. Good luck. Let me know if you have any questions, and I'll be back with the answers in a couple minutes. All right. Fatima has given me some answers, and they look good. Yeah, they look really fine. So just take one more minute. It's 2:29, obviously. At 2:30, I'll go through the answers to this. This is not, it gets harder than this, sadly. This is just the first step, but take one more minute at 2:30, or I guess it's 2:30 now, according to my computer, but in like 30 seconds or so, I'll show you the answers. So just kind of finish up whatever you're working on. And in 30 seconds, we'll look at the answers. And good job, Fatima. That all looks perfect. All right, let's have a look at the answers here. Okay, I don't know why I secretly love this stuff. I can't explain why, but I've always liked factoring. I probably said that before in this course. I told you I really like the elimination method. I've told you, I've liked other things, but I have always been good at factoring. Believe it or not, I wasn't the best math student. It's certainly not in junior high, which for a junior high would be, for me, grade 7, 8, and 9. I was like really bad. And then something happened in high school. I started to really like math. But anyways, I don't know. I always liked factoring. So like to me, it's like solving a puzzle. We're trying to find the biggest number that goes into these sets of numbers, or what we would call terms. Ooh, I'm getting some different answers. Or no, Dustin said the answer for number 2C is 2. That'll be interesting to try. Okay, so let's look at this. 28 and 42. Now, my instinct is to start with the number 2. I always start with the number 2. I know that's not the answer here, but I think about, okay, if I can divide these by 2, let's just see what I get. And I end up getting 14, and I think 42, I get 21. And what I realize is I can also then divide these numbers by 7. And then I end up getting 2 and 3. So my GCF for these two numbers, and actually 1A is a tough one to just get started with. 28 and 42, my GCF is 14. Now, where did that come from? Well, there's a few ways you could find out that it's 14. You could just trial and error, meaning do this as many times as possible. Or you could do what I did. I divided it by 2, then by 7. 2 times 7 is 14. That's how I got 14. Okay. Don't worry. You won't see something. Typically, you won't see numbers as big as 28 and 42 when you're doing this in a math course, but it's good to know. Okay, what about 12, 24, and 30? So this is another example where, first thing I would do is just divide all of these by 2. That's what my gut is telling me. And I get 6, I get 12, and I get 15. Now, when I think about these numbers, I really think I can divide all of these again by 3. And sure, I get 2, 4, 5. That's as low as I can go. Now think about this. I divided these terms by 2 and 3. So my GCF here is 6. I can divide all of these numbers by 6. I divided them by 2, I divided them by 3, and the total is 6. Easy, nothing to it. Now, let's get to my favorite ones. I don't want to scroll too much. Okay, this is fine. Okay, so I asked you guys to do B and D, and I said I would do A and C. So let's have a look at A and C here. A, 5 and 10. So I can definitely remove a 5 from both of those numbers. And then guys, when I say remove, I mean divide. So I can divide each of these numbers by 5. And I can also remove 1x. So my GCF is 5x. Now, okay, I recognize maybe that doesn't make sense. So the GCF is 5x. How do I know? Where am I getting the 5x? Well, what I'm trying to do is I'm trying to think of a number that I can divide both of these numbers by and still get a whole or normal number. 5x squared divided by 5x is just 1x. 10x divided by 5x is just 2. This, you're gonna I'm not doing this for no reason. You're gonna see why I do this in a minute, but the GCF 5x works. And you're going to see why I did this step in a minute. This is factoring. Okay, so what about C? Okay, for C, I think Dustin in the chat just said 2, and I think you're right. The only number I can remove from all of these is definitely a 2. I don't know why my brain just stopped there. Yeah, I can only remove a 2 from all of these. That's it. All right, cool. So what about the 2 that I asked you guys to do? Okay, so GCF. Let's see. Well, I have a 9 and a 3, so I can definitely take a 3 out. I have 2 x's and 1 x, so I can only take 1 x away. You can only take the lowest number, and I can take 2 y's away. Whoops, that's not a very pretty y, is it? So, again, I'm going to erase this for a second. Hold on. All right, there's a reason I did that. How do I know that 3xy squared is the greatest common factor? Well, when I divide these numbers by that, I would get 3x and I would get 1. So this works. This is my GCF. Again, there's a reason I'm doing this. It's like I'm slowly revealing the plot of a movie. So you'll see why I'm actually showing you this part in a minute. Nasser raised his hand. Do you have a question?
Yeah, hello, Mr. Mark. I was asking that should we go further with the solution or just find the GCF?
Oh, that's a good question. Okay. No. If this was a question on your test, this is your answer. Sorry, what I'm circling right now, that's it.
Okay.
You don't have to show me anything, no.
So after I find my GCF, I don't need to solve number C.
No.
I mean in C, 3x, whatever. I don't solve it further, yeah?
No, not for this question. There's a reason I'm doing this, which I'll get to after this topic. But if I just ask you the GCF, just give me the GCF. That's it.
Okay, thank you.
No problem. One thing I'll mention actually, and Nasser brings up a really good question. How far do you go with math questions? And the answer I'll tell you is, if you have time, go as far as you can. What I mean is, if you're doing a math test or your math exam, and I'm not there, maybe I'm sick or I'm not in the room, write as much as you can. No math teacher in the history of the earth, I hope, if there is a math teacher like this, they're not good in my books, but no math teacher in the history of earth would take off marks for you writing too much or for you putting too much in there. This isn't communications or English. Sometimes in an English course or communications course, your job is to be succinct. What I mean by that is your job is to keep things short and simple. Math is not that case. You guys write whatever you want and whatever you can in the time. You'll never be penalized, meaning I'll never take off marks. However, to simply answer Nasser's question, if I ask you for the GCF, this is all I want. And then Nasser said, do I need to show this part in question C? And the answer is no, but I'm doing this for a reason, because in the next part, you will need this. So I have a plan, trust me. Okay, so let's look at 2D. What can we take out of 2D? Okay, 6, 8, and 12, I guess you could take a 2. You can't take a 3 or a 4, so we would be able to take a 2 away. And we could take 1x away. Now we can check. So this is it. To answer Nasser's question, done. Halas, 2x, you're finished. But I just want to see what happens. I want to make sure when I take 2x away, everything is cool. So I would get 3x squared, I would get 4x, and I would get a 6. Perfect. Everything works. There's no other number I can take. Like what I'm doing is I'm looking at this guy. I'm putting a square around and I'm just seeing, is there any other number I can take from them? And there's not, besides a 1. Now this leads me to factoring. There was a reason why I was writing these little guys down here. I was secretly, without you knowing, although maybe some of you knew, I was secretly factoring these numbers. So let's look at this. This is really, really important. Again, for anybody going into other math courses, this is so important. So just give me 1 second here. All right, so factor 9x squared plus 6x by removing a greatest common factor. Okay, give me 1 second here. Just gotta open up my tools. I want to change my color. I'm feeling like I'm going back to red. Okay, now I want to factor this term. What factoring means is removing the GCF, but keeping it there outside of the term. I don't know how to say this in simple words, but you remove the GCF, you're kind of like reversing the calculation. So like okay, let's look at the answer. Okay, so go down to the bottom here and just look at the answer. What factoring does is it simplifies an expression in a way where we can kind of, well, we're going to work with this later, but we can reverse it. What I mean is this over here on the right is what we would call in math a factored equation or a factored expression. I can go backwards anytime by using the distributive property, which we learned, I think, in topic 2, maybe. 3x times 3x is 9x squared. 3x times 2 is 6x. So what factoring does is we remove the GCF and then divide that, like, again, when I say remove, I mean divide. So we remove the GCF, or we divide the initial polynomial by the GCF, and we write them side by side. Mathematically, we are changing nothing, right? Remember, like, think about this. A mathematical equation, you can't just randomly change numbers. Think about when we're doing algebra and you add something, but you add it to both sides of the equation. You know, if I had x plus 1 equals 2, and I want to subtract a 1, I do it from both sides. Factoring is similar. We're not changing the equation. We are just, I want to say, simplifying it, meaning we're removing a common factor, which can help us later. This is all like building blocks. There's a place I'm trying to go here. Okay, so let's look at example number 2, and then I'm going to show you a couple, and then you guys are going to practice. We might get to trinomials today. No, I guess we will. Trinomials can be very tricky. Anyways, okay. So let's look at this example. I'll show you one myself, and then I'll let you guys, or ask you guys, to practice. So factor 20, I'm up here, guys, up at the top of the page. It says factor 20x cubed y squared z cubed minus 28x, blah, 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 blah. Yes?
You will ask about by removing the GCF specific question, or
Are you asking if this will be on the test?
no? I asking about if you will ask about a specific solution. I can get the GCF and stop.
Okay.
So how I can, you want more?
Yes, I want more. Okay. Yes, that's a great question. Okay, so the question was, guys, and I hope I'm getting this right, is, if I find the GCF and just stop, is that right? No. If you see the word factor, like I cannot express this enough. I can circle it 1,000 times. Factoring is not finding the GCF. Factoring is going here. So this is what I want. And I'm going to show you this right now. So to answer your question,
Yeah, I got it. Thanks.
you got it. Okay. But like just to, maybe on the test or something, I might say, what is the GCF? If I ask you for the GCF, this is fine. But the minute you see factor, I need this down here. And again, this is so important for further math. I don't know if you'd ever use this in real life, right? A lot of times people hate math because it's like, when am I ever going to use this? I do not know in real life if you'll ever use this, but I promise you, if you go further in math and you're doing, engineering or med science and you're doing calculus, you need this. This is so important. So I want you to factor here. First step to factor this is I find the GCF. I can remove from 20, 28, and 36. I can remove the number 4. I can also get rid of, okay, so let's look here. Guys, I'm up here, follow my pen. I can remove 3 x's, 3 x's. Ooh, I can only remove 2 x's. What about the y's? So I got 2 y's, 3 y's, 5 y's. So I can only remove 2 y's. And z3, z4, this guy does not have a z. So the z is not in my GCF. So I can remove a 4. Like, again, think about it. From every one of these numbers, I can take away a 4. I can take away 2 x's, at least. I can take away at least 2 y's, and I can take away, well, no z's. Now what I do is I divide each one of these terms by that polynomial to see what's left over. I'm sorry about that. So I divide each of these terms and I get this. Now putting it all together, the GCF gets written and what's left over gets written with brackets around them. This is called factored form. This has been factored. Nasser, you have a question?
The GCF should be included with the answer?
Yes, 100%.
Okay.
So we have the GCF, and then we have the factored answer next to it. 100% you need the GCF. Like, this is so hard to like, I wish I was with you. I wish I was like in the classroom with you guys. Like all I'm doing is I'm not changing this equation or expression. I'm what we call in math simplifying it. I'm factoring, I'm removing a common term. And you, like, some of you guys might wonder why, like, who cares? Why would we remove a common term? Like, who cares? But there's a way in math soon, you might see this Sunday next week, where we can really simplify equations based on this. Okay, so let's practice. How about, I can do F later, but let me try A and C. And then I'll get you guys to try B and D. Okay, so A, obviously I'm starting with an easy one. 12. So guys, I'm doing A. 12 and 6. Well, okay, GCF here if I have the numbers 12 and 6, I can definitely take away 6. Okay, what else? Now I got them in the chat. I haven't opened the chat yet, but I have a feeling the chat is going to say 6y, I hope. No, it's a private message. Yes, this is a private message that asks if this is topic 12. This is topic 12. Okay, so GCF is 6. Not only 6. What else can I remove from these? I can also remove a y, right? I can remove a 6 from 12 and 6. I can remove a y, no problem. Now, just to check my answer, I'm going to divide both of these numbers by 6y. And what I end up getting is 2y plus 1. So the answer is 6y, 2y plus 1. It's multiplied together, so I use brackets. This is my answer. I need to see this. 6y outside of 2y plus 1. Again, guys, what you're doing, just look at what I'm writing here. You're doing the reverse of the distribution property. So 6y times 2y is 12y squared. 6y times 1 is just 6y. I'm reversing the distributive property. This is what factoring is. I'm pulling away a common term to reverse this. There's a reason why I'm reversing this too. But anyways, let me check the chat and then I'll do C and then I'll ask you guys to practice. Okay. I got a couple things happening in the chat here. First, everybody can see this. This is from Abdullah. Abdullah says the answer to B. And I haven't asked you to do B yet, but no, that looks good. Okay, so we'll worry about B in a minute. The other message I get, this is a private message, so you guys can't see it. Oh, Fatima got the same for B as well, so that's good. But this is a private message, and this says, for number A, this is a really good question. Okay, the chat message says, is it the same if I said 6y times 2y? No, it is not the same. So to answer your question, and Dustin just did D, the answer to this is not 6y times 2y. It is 6y times 2y plus 1. And really what you have to ask yourself is, are these the same thing? And the answer is no, it's not. It's not. So you have to include the 1. Okay, so I'm getting a lot of messages in the chat that people are solving question B and D. So I just want to show you C, and then I want you guys to try these. Okay, for question C, GCF. 10, 20, and 35. I think the biggest number I can take away from those is 5. I don't think I can take anything bigger. What about the x's? I can only take away 1 of those x's because the last term only has 1 x. So I'm going to divide each of these terms by 5x. Oops. And see what I get. 2x squared, I'll be left with 4x and 7. So my answer is 5x outside of 2x squared plus 4x plus 7. Okay. I know some of you have already done this. Some of you guys are actually amazing. Maybe you remember this from high school, maybe not, I don't know. But take 2 or 3 minutes to try this. And then I have one more topic to do today, and halas, we're finished. I am going to do trinomials, which I'm kind of afraid to get started. But anyways, we will do this. So try B and D. If you want, you can try E and F as well, whatever, but take a couple minutes and try B and D. All right, so I'm getting a ton of answers here. Ooh, yeah. Okay, so Sultan and probably others, maybe. No, it's just Sultan. Oh, no. No, it is. Sultan has corrected me for number C. I did make a very important mistake in number C. So thank you for that. And everybody else is doing all of these. Like, oh, wow. So B, D, E, and F. Okay, so let's check our answers. Now, first things first. Before we check our answers, what did I do wrong in number C, right? What's the issue? The issue is when I divided 35x by 5x, I clearly forgot that it was negative. So this should have been -7. And I really, really, truly thank Sultan for that, because this is the kind of thing, right? If you're not careful, you're not checking your answers, these are the common mistakes you can make. So thank you, everybody, for that. Okay, let's check out the rest of these. And people are going crazy. They're doing F, they're doing E. So let's quickly look at the answers to this. I think you guys... there's two options. Either I'm an amazing teacher and you guys are understanding this right away, or the other option is you remember this from high school, but I think you guys are doing really good on this. So let's check our answers. All right, so B, GCF. I can totally take a 4. I don't think I can take anything else. I can take away an A. I can take away 1b and 1x. So the answer to this would be 4abx, and then you would get 2x minus 5b. All right, I think that's correct. Let me check the chat here. Yeah. Okay. So like, I'm looking back through the chat. I know Sana, you forgot your 5, but that's a very common mistake. All right. Cool. Everybody looks good. All right. What about D? Okay. So D. Like I do like these. It's like solving a little puzzle. I can take a 3. I can take an A, and I can take 1B. So 3AB, what I'm left with is just a B. I'm left with 2A, and I'm left with a -4. All right, so that's the answer for D. So like what I'm doing, guys, is I'm taking this GCF and I'm removing or dividing it in each of these terms. So that's where I'm getting the answer. Let me check the chat here. All right, cool. All right, yeah, I'm not going to do all of these, of course, but I mean, since so many of you have done E and F in the chat, why not? So the GCF, 24 and 16. I guess the biggest number you could take from that is 8. You could certainly take 2 Y's, and you could certainly take 3 Z's. So 8y squared z3, and what's left is 3. That's it, minus 2y squared z2. Remember, I'm dividing 2 y's and 3 z's or z's if you're Canadian, meaning I subtract the exponents. So when I divide or remove 2 y's, I literally take away 2 from 4. And when I remove 3 z's, I literally take away 3 from 5, removing. Okay. I don't agree with this here, but anyways, you don't have to do this, but it says when an expression begins with a negative, use a negative GCF. You don't actually have to do this. In my personal opinion, no. However, it's not wrong to try and remove. We could, I don't know why it tells you to do this. But anyways, we could remove a -3 here. You could. Now, some of you guys might be thinking, well, wait a minute. This is not a negative. Why are you trying to remove a negative? I honestly don't know. I don't think it matters. So I would kind of ignore this. You could just remove a 3. You don't have to remove a negative. Anyways. It's telling you to remove a negative, so you remove a -3. We can remove 1x and we can remove 2 y's. Now, as I was explaining that, Nasser raised his hand. Did you have a question?
Mr. Mark, how can I level up the exponents between the variables? Like, how do I find out like how to subtract the exponents? Like what numbers do I have to use?
So we did this a lot, like the great question. We did this a long time ago, so you might want to review earlier classes, but just to remind you, so if you had, let me pick a different color. I'll write it here at the bottom. So, okay, if you had x cubed and you were, let's go crazy with this. If you had x to the 12 and you were dividing x to the 5, what you do to solve this is you subtract the exponents. So x12 divided by x5. Now, like literally think about this. You have 12 x's, right? So 1, 2, 3, 4, 5, 6.
Oh yeah. No. I know this step, but I was asking about if you found the GCF and if you try to include the variables with it, how do you like? For example, on number E, like how do you manage the exponents like with the GCF?
I kind
Like
of.
like on E, there's that -16 y4 and z5.
Yeah.
Should I put like y4 and z5 with the GCF?
No. Oh, okay. No. So what you're doing, like, okay. This is tough. Good. It's a great question. It's tough to answer, but it's a good question. So, like, if I have 24y squared, I'm just writing the equation again. Okay. The first thing you do is you remove the GCF. So
ناصر ما ادري شو اسمك، لكن هي انك تاخذ اكبر عامل مشترك فيهم. زين.
ايه اكبر عامل
لما
مشترك.
تاخذ اكبر.
فهمت. بس انا
فهمت؟
سؤالي هو انه شنو، انه شلون اطلع الحين مثلا الواي 4
إيه؟
والزي 5. زين شلون
إيه؟
اطلع يعني مثلا مع الجي سي اف شلون احط الواي، يعني احطهم نفس الاكسبوننتس اللي على الفاريبلز ولا شو يسمونه؟
هون شوف المتوسط، شوف اكبر عامل وخذه حطه برا عند الجي سي اف. عقب سوي الملتبلاي بتكون يعني اكبر عامل مشترك ضرب القسمه مالت شو اسمه مال العامل المشترك.
يعني اقسم بين حتى الفاريبلز يعني مال الاكسبوننتس مالهم ولا؟
على ما اظن ايه.
Sorry, Mr. Mark. I think he answered my question.
Okay, no, I love it. Okay.
No problem.
I was sitting here with a big smile on my face. That's good.
No,
Okay.
I mean, I was confused because no problem. He answered my question.
Excellent.
Sorry
Okay.
for the.
No, that's cool. I love it. If I wish I knew Arabic, but I tried. It's a very hard language to learn. I really respect you guys because, like learning like French is easy because it's like English, but learning Arabic, so tough. So anyways, thank you for that, for the explanation. And just for anybody else wondering, kind of take it piece by piece. So, and Nasser, I think you have the answer, but I'm just gonna, because you've kind of got me started, take it piece by piece. So I have 24 and 16. The biggest number is 8. I have 2 y's and 4 y's, so I can only remove 2 of those. And I have 3 z's and 5 z's. I can only remove 3 of those. That's where that
Okay.
came from.
Yeah. Okay. Thank you. Now I.
Yeah. I don't know. This is tough. It's so hard to teach online, but I hope that makes sense. Okay. Guys, I got to be honest with you. F, I think this little yellow block in F is I don't believe him. So I'm a sciencey guy. I come from science background. I'm chemistry, engineering type of background. I don't believe Mr. Yellow Box here. It says when an expression begins with a negative, use a negative GCF. My heart says that that's not true, but if it is true, the GCF here, I'm going to take. It just hurts me to say this, but anyways, I'm going to take away a -3. And here I'm going to take away a -3, but this is going to cause an issue. But anyways, I have 2 x's and 1 x, so I can only take away 1. I have 2 y's and 3 y's, so I could take away 2 y's. There we go. So now I'm going to remove this term. I hate number F. I really feel I'm doing worse by explaining number F than if I never showed you F. Anyways, so I'm going to remove a -3xy squared from the above, meaning I'm going to divide 3xy squared into each of these. You guys don't understand how much this is breaking my math heart. So I would get a positive 3 x, and that's it. Now here I have a positive, and I'm sorry for the text jumping everywhere. I have a positive and a negative. So I would get negative 1 y. Yep, that's it. So you don't need the 1. Some of you guys might have said just minus y. That's fine as well. I don't know. I truly, in my heart of hearts, my mathy heart says you really don't need to worry about the negative. You could do this differently, but this is what the book is saying. What does the chat say? GCF for F. Did I get it wrong? No. Okay, I'm good. Shahad, I don't know if I'm saying your name right. Shahad Ghazal. I totally apologize if I'm saying your name bad. But yes, thank you for that. All right, cool. So do I want to move on? That's the question. It's 3:12 on a Thursday afternoon. I would love to do this, but I'm worried because this is kind of a complicated topic. Just give me 1 second here. I got to think. I got to judge my life here. Trinomials. Okay, here's what my final decision is. I think we've done enough for today. What I recommend, however, I recommend a few things. 1, get your assignment done this weekend. We have covered everything you need for your assignment. So first, focus on your assignment, get that done. Second, if and when you finish your assignment, think about watching some old videos or trying some of this book, especially questions we haven't done. And third, if you guys are like pro at factoring, meaning like you're very comfortable with factoring, feel free to try or look at page 8. We're going to start with page 8 on Sunday. So that's it for me today. I really hope I didn't confuse anybody. I hope you guys
Looks
have
fun.
good weekend. It does look fun.
Yeah.
I honestly, I love this. I love factoring trinomials. I don't know why, but anyways, have a good weekend, everybody. Take care. Be safe. Don't forget to wear a mask. And if you have any questions, let me know.
Thank you very much, Mr. Mark.
Thank you, guys. Thanks, everybody. Take care. I'll put the videos up on YouTube now, by the way. Thanks, everybody. Thanks, Mansoor and everybody.
Thank you, sir.
Thanks.
Thank you so much.
Thanks. Thank you, Sana and everybody. Check YouTube in an hour. The videos will be up in less than an hour. Thank you.